Welcome back to my channel Techno Namaste. I am Dr. A. Navanita, Assistant Professor in EC Department, Mahatma Gandhi Institute of Technology. So today I am going to discuss about the instruction. In my previous videos I have discussed about addition, multiplication, subtraction and multiplication. Then now I am going to discuss about the div instruction, which is used in the 8086 for writing the assembly level language programming for doing the division operation by your CPU 8086. So div is nothing but a div is a command which is given by the programmer to 8086, that is nothing but CPU, to do the division operation. Okay, so it will be doing a division operation in the ALU which is present in 8086. The syntax which is used for writing in assembly level language for division operation is nothing but every programming language is going to have some predefined function, isn't it? So that predefined function is going to have syntax. Remember that whichever the programming language you are using, each line of the programming language signifies that it is going to do some work by in the hardware. So here in this one, div instruction makes it to do, once this instruction is executed by the CPU, it makes the CPU to do the division operation. So with this div instruction, only one operand will be used. So this operand can be a register, or it can be a memory location which is given like this, okay, or it can be a memory location where the address is present inside your register. Okay, so this is a register with a bracket is written, means SI is a source index register. A bracket is written over that. This represents a data present in the memory location whose address value is present in the SI. Okay, so instead of this we can take a data also. So any data you can take, and this data it will be taken, whatever you have it will be as a one operand. Next one is nothing but you can take a register. Okay, here I am taking a register as BL. So whatever the operand you are using in the div instruction, this operand will be taken as a divisor. So this operand can be 8-bit or 16-bit. First we will discuss with the 8-bit and next we will get into the 16-bit. Okay. So here in this one, whenever you want to do the division, already you know that you require division will be performed with the numerator divided with the denominator. So whatever the numerator which you are taking, like numerator x by y, so x will be taken, that is nothing but numerator will be taken as a dividend and denominator will be taken as a divisor. Whenever you take div BL, the default dividend, it can be any operand, a register or a memory location or user data. Divisor can be anything, but it should be of 8-bit. The default dividend for this instruction will be AX. So here whatever the BL you are taking is a divisor, that is a denominator value, and the dividend default it will be taking it will take as a 16-bit content of AX register. When AX 16-bit is divided with the BL of 8-bit, when division is performed, you know you are going to have the quotient value and remainder value. Quotient value will be stored in the AL register of 8-bit and remainder will be stored in the AH register of 8-bit. Okay, so here think I have taken in the instruction BL content as 05H and AX content as 00FH. So when this instruction is taken by the 8086 and it is executed 00F by F 00000F by 5, you are going to get the quotient as 03H and remainder is equal to F is nothing but 15. 15 divided by 3, how much? Quotient 3 and remainder 0, isn't it? So quotient you are going to get as a quotient I am representing with the Q and the remainder I am going to represent with the R. So quotient you are going to get 03H and remainder you are going to get 00H. So okay, so instead of 8-bit, if you go for 16-bit, that is instead of BL if you go for BX. Okay, so what it is going to take here, whatever the content are there, here dividend will be content of AX and dx. That is nothing but ax is of 16 bit, and dx 16 bit. So total 32 bit it will be taken, and that is a divisor. That is a dividend, and divisor will be your bx, whatever the operand you have taken. That is of how many bit? 16 bit. So 32 bit will be divided with the 16 bit. After division, whatever the quotient you get, that quotient it is going to store in the ax, and remainder it is going to store in the dx. Okay, so here you have to vary the value. Instead of bl, you have to take the bx value, and you have to take the dividend in the ax and dx. So after division, whatever the value you get, quotient and remainder, that you can see in the ax and dx if you go for 16 bit. Okay, so here this is whatever you have verified in the theoretically, that you can observe in the software tool MASM or the DOS box. In the system you can check out the results. If it is 8 bit divisor, quotient you can see in AL, and remainder you can see in age. If it is 16 bit divisor, then you can see that quotient will be in AX and remainder will be in the DX. So here in this one, whatever the div instruction you have used, inside your div instruction, how div instruction has to work. A program is written in the assembler which is present in your DOS box or MASM. According to the program written, this it will take the content of whatever the dividend are there, and it will produce the quotient and remainder respectively. Okay, so this is the way your division instruction is going to be work. I think if you are given the information about how it is going to work, if you like my video, subscribe it, like it, comment it and share it. So if you have any doubts, you can place your number and you can ask your doubts, and I will be sending my answer for the questions which you asked. Okay, so thank you once again.